Hello everyone, let's dive into a fascinating area in the world of AI and data, text-to-SQL. So, what is text-to-SQL? In simple terms, it's about translating human language questions into database queries, specifically SQL commands. Think about it, instead of needing to know complex SQL syntax, you could just ask a database a question in plain English, like, show me the names of all customers who live in California. This technology makes interacting with databases much easier, especially for people without technical skills. It's super useful for things like generating reports, getting insights from data, or even powering chatbots. Now, large language models, or LLMs, have gotten really good at this, often generating syntactically correct SQL. But there's a big challenge: semantic errors. This is when the SQL looks right and executes without crashing, but its meaning doesn't actually match what the user asked for. This leads to confusing or wrong results. Evaluating these text-to-SQL models, especially on complex real-world data, is also tricky. This is where benchmarks come in, and a really important one is BERD, which stands for the Big Bench for Large Scale Database Grounded Text-to-SQL Evaluation. BERD is a pioneering dataset because it focuses specifically on the impact of extensive database content on text-to-SQL performance. Why is BERD challenging? Well, it's huge. It contains over 12,751 question SQL pairs and is built on 95 large databases totaling a massive 33.4 gigabytes. These databases cover more than 37 professional domains, everything from healthcare to blockchain. Unlike some older datasets, BERD's databases are designed to be realistic, with messy data and complex schemas. It really pushes models to reason about massive database content, integrate external knowledge, and generate efficient SQL, which is crucial for real-world applications. The main way performance is measured on BERD is through execution accuracy, EX. So, how do we tackle those semantic errors and improve performance on challenging benchmarks like BERD? That's where the SQLFixAgent framework comes in. This is a consistency-enhanced multi-agent collaborative framework designed specifically to detect and repair erroneous SQL queries. Its core purpose is to fix those tricky semantic inconsistencies that LLMs often produce. The SQLFixAgent framework uses three main agents working together. 1. The SQL reviewer. This agent acts like a quality checker. It first verifies if the generated SQL has any syntax errors by actually trying to run it against the database conversation. If it's syntactically valid, the reviewer then performs a sort of rubber duck debugging. It steps through the SQL and compares its logic against the user's original question and the database schema to spot semantic mismatches. 2. The query crafter. If the reviewer finds an error, the crafter gets to work. Its job is to generate multiple potential alternative SQL queries that could be correct fixes. It might do this by using the initial SQL generation model with slightly varied inputs, 70, conversation. 3. The SQL refiner. This is the central repair agent. The refiner is powered by a foundational LLM known for its strong semantic understanding, conversation. 4, 13. It takes the candidate queries from the query crafter and decides which one is the most appropriate fix. The refiner can also learn from past mistakes. If a fix attempt fails during execution, it uses that feedback, stored in a failure memory, to guide future repair attempts. 70, conversation. This process can involve multiple attempts to get the right query, conversation. In experiments, the initial SQL might be generated by a fine-tuned LLM, and then the reviewer, crafter, and refiner agents, powered by a separate foundational LLM, work together to fix it, conversation. The results show that SQLFixAgent is effective. It was tested on BERD and other benchmarks, 70, conversation, and consistently improves the performance of baseline models. On the BERD benchmark specifically, it achieved an execution accuracy improvement of over 3%. Another benefit is its higher token efficiency compared to other methods, because it only kicks off the repair process when an error is actually detected. This makes it more practical for real-world use. So, SQLFixAgent demonstrates a powerful approach using collaborative agents to address the crucial problem of semantic accuracy in text-to-SQL, leveraging the strengths of different types of LLMs to improve results on challenging, large-scale datasets like BERD. Thanks for watching. Please like and subscribe, and share your comments.